it's not blue, it's pink, huh? Okay. Yes, this year's is pink. Yep, my bad. I didn't fix that. All right, so we're going to flip back and forth between 18 and 19. Is this on 18 for you? Yes? Okay, because it was also on the bottom of worksheet 9A or something, and we skipped it. So I'm glad to know I put it on here so that I don't have to go back to 9A. All right. Tangent, guys, is slope, right? Tangent is slope. Are we good with that concept? Because it's what? Why is it slope? Okay. Rise over run. But more importantly, tangent is defined as y over x. Okay? All right. So what I want you to look at is as I rotate around, this is going to be theta, our amount of rotation. I want you to tell me what the slope is. What is the slope of this line right here? Is it 0 or is it undefined? That's what you got to know. It is 0. Okay? Now, if I did this, it might be I went up, but I went over a whole bunch, right? So if I went up 1 and over 50, that would be a really little number, yes? So this is a small slope, a small amount of tilt. Is that making sense? Okay. All right. As I increase here, does anybody know what happens right around here? Think about that. The slope becomes what? The amount of over and up is the same. So the slope becomes 1 at some point, right? That's not where the 1 would go. Sorry, my bad. Okay. But when I get past there, what's happening to the slope? I went over a little bit, but I went up like 7 times as much, right? So the slope gets really, really steep. Do you understand? Okay. What happens when I get up here somewhere? What's the slope of that line? Undefined. Okay. Now, as soon as I move past into this quadrant, what can you tell me about that slope? It's negative, yes? It's negative. Is it a little slope or a steep slope? Okay. So it's a very negative slope, right? And then when we get over here somewhere, it's still negative, but the y and the x are roughly the same. So we're moving back towards -1. And then it gets, this would be a small slope, right? But negative, like a rise of 1 or go down 1, but over a whole bunch. So it would be, 1 over 10 or 0.1, very small slope, but still negative. Then what happens when we get back to this line? That's back to 0. Okay? Now, after that, it's going to repeat because the slope of this line is the same as it was over here somewhere, right? The slope didn't change. So it's going to go back to doing this. All right. The same is true if we rotate the other way. It's going to do this. So where was this undefined place where this... Yeah, nice asymptote. Where was that undefined place? Right here, which was at, in radians, at pi over 2, okay? And if we were to continue to go around, we'd hit that same undefined place at 3 pi over 2, because that's the other end of that line, right? Okay. So tangent is this shape. I did a crummy job of hitting the dots, but Okay. Is that an even or odd function? Or neither? Even is y-axis symmetry, so can I fold it along the y-axis and it's going to match up on both sides? Does this match up over here to something? No. What does odd mean? Origin symmetry, which means I can turn it 180. Does that look the same, roughly? Except I didn't do a good job of drawing mine symmetric. Okay, so it is an odd function, the same as what? Remember which other one was odd? Sine, because it goes through the origin and goes up and down on either side, remember? Okay. Cosine was what? Even, because the y-axis goes right through the middle of that bump, right? All right, so I found a cool website. We're going to play for 3 seconds here. 1, 2, 3, that's all we get. But, okay, this is, does that look like tangent? Okay, and here's an asymptote they drew in for us. All right, ready? So this is a slider, and I don't have to do anything. What is this telling us out here? Okay, it says amplitude. We think amplitude. But we're going to talk in a minute. If amplitude is max minus min divided by 2, is there any amplitude here? Because there's no maximum minimum. What did we used to call that? Which really we should be calling it still. Vertical stretch. Do you remember that? Okay, last semester we called something out there vertical stretch. So here's a vertical stretch. It's stretching it up faster. Does that make sense? If I move it over here, though, what happens when that becomes negative? It reflects it. But did it move? Did it still go through the origin? Okay, it just reflected it, right, when it became negative? All right, what is the B in here doing? Changing the period. Okay. As it gets bigger, the period actually gets smaller. It's an inverse. Do you see what's happening? Okay. As it gets smaller, closer. Here, where's like less than 1? Is there one less than 1? There's a 0.5. The period got much longer, right? Okay. What else does that change? It changes where this asymptote is, yes? Okay, because you're going to need to know that. H is in here. What is that? Phase shift. So that's going to move the asymptote, but it's also going to move this intercept, right? So watch what happens here. Woo, we just get dizzy, right? Slides it left and right. And what does the K value do? On the back, right back here. Yeah, up and down. Okay? But look what it does. Looks kind of cool in here, right? Woo. Okay, now that I've made you all dizzy. All right. So what it says, since tangent equals sine over cosine, and where it's undefined, yeah, we're going to go with that. Okay. This is kind of on worksheet here, the top of 19, okay? Some of this information is on the top of 19. But it says the domain is really ugly for this, yes? For a tangent graph, because there's a bunch of undefined places. So the domain is all real numbers except starting at pi over 2 and adding pi over and over. You can't have those spots. That's really ugly. I won't be asking you about the domain, okay? Range this time is all real numbers because it goes up and down forever. We good? All right, the x-intercepts, it says are n pi. What does that mean? 0 pi, 1 pi, 2 pi. Is that what it's looking like over here? 0 pi, 1 pi, 2 pi would be the x-intercepts. Okay. The y-intercept is just 0, 0. All right. It has an infinite discontinuity or an asymptote at pi over 2 and every pi after that. So 1 pi over 2. If you add another pi, that would be 3 pi over 2, right? Right? 1.5, 2.5, 3.5. Get it? All right. I'm not going to ask you to write those, but I want you to kind of understand what they're saying. It is an odd function. It has no end behavior. Even though it seems like we want to say, well, as I go off to the right, these are all going up. But does it depend where you are off to the right? Because every little bit it goes up and then the next one is down again, right? And the next one is up. So it oscillates between positive infinity and negative infinity, so it has no limit or end behavior. All right, the important thing besides asymptotes and the shape and all that fun stuff is that the period is pi. We talked a little bit about that when we were doing slope. Remember how I went as far as the 180? And then I said, now everything after that is just the other half of the slope of that same line. Okay, we hit all the values by the time we got to pi. All right, now this is what we all think of, right? Is that a 0 to pi graph? This is what I would draw in my paper if you asked me to draw a tangent graph. But that is not a 0 to pi graph, right? Here's 0 to pi over 2, and here's pi is here. So there's a 0 to pi graph, but most of us will draw this as what to what? Negative pi over 2 to positive pi over 2. Is that a period of pi still? A distance of 1 pi? All right, and remember we just vaguely talked about this when we had the little goofy Desmos calculator open. Amplitude doesn't really apply here, right? We have to call a vertical stretch, but it doesn't have an amplitude. All right, so this is, we all talked about this already, all this kind of stuff. It does say except the odd multiples of pi over 2. So 1 pi over 2, 3 pi over 2, 5 pi over 2, those are undefined places. All right. There's some stuff later today where you're going to make sure you do a little graphing, and you're going to want to be in radian mode and zoom trig. All right. This is from earlier notes. Okay. On the earlier notes, it said this. Is that still true for tangent? It's just going to be pi divided by b. Okay. So it says tangent has a period of only pi. So the new period is just pi over b. This is at the top of 18b. Can you find the top of 18b? All right, so what would, it says, recall that the period of a tangent of a trig graph is changed when the factor b is multiplied by t. So we have y equals some trig function bt. When we have this b value in here, it changes the period. The new period is the normal period divided by b. So for sine and cosine, that normal period was 2 pi. But for tangent, it's just pi. So when we saw a 3 there with a sine graph, the new period was 2 pi over 3. When we saw a cosine with a 5 in, the new period was, okay, I'm going to write this down just because there was some confusion on the quiz for some of you. The b is just the 3, the period was this. The b is just the 5, the period was this. Okay. What do we have to see here with our little 2 eyes? We have to see that it's a tangent. So while b is still 3, the period is now 1 pi over 3. Yes, because it's a tangent. And this one? Yes, the b is 4, but because it's a tangent, the period is pi over 4, not... That looks like I wrote Miss Soper's name on there. So the period is pi over 4. Anyway, okay. What's going on with this one? This is 19A? Maybe? I know, I told you at the beginning I was going to switch back and forth. The bottom of 19? Is that where I am? Okay, the bottom of 19. They want us to sketch a tangent graph. A negative tangent means what? Reflected, so the shape is going to go this way. Is it shifted left or right, though? So what can you tell me about the origin? Still going through there, right? What is this going to do? Change the period to what? Pi over 4. Now, okay. Is it going to make them smushed up or stretched out? In relationship to a normal period of pi. Yeah, they're smushed. Okay, going this way. What the requirements for sine, cosine, or I'm sorry, cosecant, secant, tangent, and cotangent graphs. I don't have it on this slide. It's on another one, but it says you have to draw 2 periods. You don't have to give me a bunch of ordered pairs. For these, you have to give me the equations of 2 asymptotes, and you have to give me 2 intercepts. Okay? So one is going to be 0, 0. Yes, you can do that. What's this next one? Well, how long until it's back at the exact same spot? Pi over 4, right? You told me that's the period? So it did a down and an up, and it's back there again at pi over 4. Okay? So over pi over 4 up 0. All right, so I need the equation of at least 2 asymptotes. What can you tell me? Describe. Don't tell me an ordered pair or an equation, but describe for me in words. Where is that? Halfway between 0 and pi over 4, right? What's half of pi over 4? Okay, so this is pi over 8. How do we figure out the next one then? Because if there was one here, the next one repeats a period later, right? So if we add pi over 4 to that, or pi over 8 plus a period. Do we need to get our calculator out? Because some of you must use the calculator. I know this of you. 1 divided by 8 plus 1 divided by 4. Math, enter, enter, is? Okay. Okay, what if we went back this way? Yeah, there's symmetry. Do you see the symmetry? So this should be negative pi over 8. If we kept going, the next asymptote would be at negative 3 pi over 8, right? Got it? What you don't have to give me is ordered pairs on the graph other than the intercepts. Everybody good? Questions? I should write x equals, yes, for the equations of those. I don't think I would get picky about that on the quiz, all right? If you just label where they are, I'll be happy. All right. What about here? Oh, hating this question, but okay. If we just, tell me what you know, yes. This is a vertical shift down 5. We could have put it on the back, right? It could have said negative 2 tan t minus 5 is the same thing. Clear on that? Okay, what else is going on? This 2 is a vertical stretch. We think of it as amplitude, but it's just stretching it up twice as fast and down twice as fast. But the negative means it's going, the shape is going this way, right? Oh, that's a really bad one. Okay, I'm going to go with the down 5 first. the origin has slid down there. So it's doing this. I tried to make it a little steeper than usual. Okay, guys. So this is what I did here. I think I graphed negative tangent -5. And then on the calculator, can you see a difference between that? Oh, I think here I did -2 tangent t -5. And then I did them on the same one. Can you see that there's almost no difference? Can you see anything? Here, I'll make it a lot bigger. Can you see that the difference of the vertical stretch is minimal, right? It doesn't change where the asymptotes are, and it doesn't change where the intercepts are. So I'm not really worried about it. Okay. So back to this question. It's going to repeat over here somewhere. Okay, that's really bad. We're used to that by now with Hofbauer. Okay. Yeah. Okay, one is skinny, one is fat. That's because this asymptote should be much closer. Oh, look at there. I get two halves of an asymptote. Or 3 little pieces. Anyway, okay. How often until it repeats and is back here? Yeah, there was no B value in here, right? So the period is just pi because it's a tangent. So this was 0, -5, and this is pi -5. Good call. So what's halfway in here where this asymptote is? We have a asymptote at pi over 2 and -pi over 2 over here, right? You could just do those two and I'd be good. What's the next one? You got to have 2 ordered pairs and 2 asymptotes labeled, okay? What's this next one, though? Everybody good? Because pi was here. Half a pi, 1 pi, 1.5 pi. Okay. I should say 3 asymptotes, but I think I said 2 on the quiz. We good? All right. Back to 18a. What have I graphed here in a little dotted graph for you? That's a sine graph, yes? Okay. So this is the reciprocal of sine, yes? Cosecant is the reciprocal of sine. What is the only number that's its own reciprocal? 1 and... No, what happened? That was a problem on the quiz for some of you. What's the reciprocal of 0? 1 over 0 is undefined. Okay, 1 is its own reciprocal and -1. Okay, so this pair up here, that ordered pair right there was what? Okay, the y value was 1. If it's a sine graph, there's some ordered pairs. What's this one right here, guys? 2 pi. So this one is 1 pi. So what is this ordered pair up here? Okay. Pi over 2, comma, 1 is that spot right there. And it's not going to move. Where's another spot that's not going to move because it's its own reciprocal? Anything that's down at -1. Okay. So what's this one down here? 3 pi over 2, -1. This would be, anybody know what this one is over here? Yep, it's symmetric, right? So this is -pi over 2, -1. This one, 1/2, 1, 1.5, 2. What's 2.5? 5 pi over 2, +1. Also not going to move. Okay. What is the reciprocal of 0? Undefined. So where sine was hitting 0 right here, what am I going to get? An undefined place in the graph, yes? a nice straight undefined place. It hit the 0 at the origin. It hits at 2 pi. So x equals 0, x equals pi. That's a 0. X equals 2 pi. Those are all asymptotes. What would this next one be out here? Or this way? Yeah, this would be 3 pi. They're just going by pi's, yes? Okay. Now, I have not drawn, I have so far some ordered pairs, but that's it. Nothing else is part of the cosecant graph. The asymptotes guide us, but they're not actually the graph. Okay, if this stays at 1, tell me what happens when I do the reciprocal of a number like 1/10. I get 10. What happens when I do the reciprocal of 1/2? I get 2. What happens when I do the reciprocal of 8/10? 10/8, which would be 1 point something, right? Just a little over 1. Okay, back here I'm down to 10/8. Back here I'm down to 1/2 again. What was the reciprocal of 1/2? 2. Way down here I'm at 1/10 for a y value. What's the reciprocal of 1/10? Okay. Does this look familiar to anybody? You probably, if you had regular algebra 2, you definitely did not see these before. I don't even know if you did them in honors algebra 2. Okay. In trig, I hope you saw them, but if you took trig last semester, but I know only a couple people in this class did. It is not a parabola because a parabola gets forever wider and this one approaches asymptotes, okay? But you get the idea. It looks like a parabola, yes. All right, going this way. Oh, why did I do that? I didn't talk your way through that one, but it's the same thing, right? A negative number's reciprocal of a tiny one is going to be a very negative number and so on. So what it does, guys, everywhere it was 0, it's now going to have an asymptote, yes? Everywhere it was 1, it's going to stay at 1. And then all these little loops are going to flip over and get arrows. Say that again. Then you, I always draw the reciprocal function first. You would stretch, I would draw 2 sine x and change the amplitude. And then you would flip, oh, we're going to do some of those, yeah. You're going to flip those little pieces over. All right. So that's what you have to do. You have to draw 2 periods, give me the maximum or minimum points, which I did. Those 4, that's a minimum, a maximum, minimum, maximum, minimum, right? And some asymptotes. Okay. So this is the actual cosecant graph on 19b, and it tells you that the range is everything except multiples of pi. So 0 pi, 1 pi, 2 pi, 3 pi are all asymptotes. It is an odd function with a period of 2 pi. All right. So if you learned anything, this should go a little bit faster. What's the reciprocal of 1? 1. So that ordered pair is 0, 1, yes? Okay, what's this ordered pair right up here, guys, on the, that's a cosine graph, right? So that's 2 pi 1. Everybody okay? Because that's, the period is 2 pi for a cosine. All right, halfway in between there was a minimum of pi negative 1. So if this is 0, this is pi, this is 2 pi, what's this next minimum? 3 pi negative 1, and over here would be negative pi negative 1. Okay? How do we know where to draw the asymptotes? Where the original function had zeros, because there is no reciprocal here. There is no reciprocal here. or here, or here. Okay. So, where were those falling? What's halfway between 0 and pi? Pi over 2. What's halfway between 1 pi and 2 pi? 1.5, which is 3 pi over 2. So now what are we counting by? 1 pi over 2, 3 pi over 2, 5 pi over 2. This would be a negative pi over 2. Okay, how do I finish drawing this? I take all the little bumps and I flip them over. The max and mins switch. A max becomes a min becomes a max. Not that bad? Okay. But what made it easier was I had graphed the reciprocal function for you first, okay? All right. This time, guys, the asymptotes were at pi over 2, 3 pi over 2, etc. So they are at the odd multiples of pi over 2. All right. Oh, we got to do another one, cotangent. You know what? Let's find a problem we can practice with a secant. Here, let's do this problem. Can you find number 2? I don't know what page this is on. What is it? 18? 18b number 2. Okay? Before we talk about cotangent, let's get through one practice on this. I want to graph first, guys. I want to graph. I don't need to label every little thing, but I want to graph 3 what of 2x? Yes, the reciprocal. So I'm going to graph 3 sine of 2x. Okay? So it's a sine graph. What's the amplitude? So this is 3 and this is negative 3. It finishes by where? Period is pi. So this is pi where it finishes this cycle. So this is pi over 2. And this guy out here, 3 pi over 2, negative pi over 2. Okay, why did I label all those? They were the intercepts. What are they going to be on my cosecant graph? They're going to be the asymptotes. So there's an asymptote here, 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 and here. I drew a lot of asymptotes. But it said I had to draw 2 periods, yes? Okay. Now what? All these little U's are going to do what? Reflect. So this ordered pair was what? Because we have to label a few ordered pairs. Halfway to pi over 2 is pi over 4, 3. And this guy down here, 1 pi over 4, 2 pi over 4, 3 pi over 4, negative 3, yes? All right, over here would be a negative pi over 4, negative 3. So what color is the actual cosecant graph on my mess? This graph is green, okay? The blue is the sine graph. I used it to guide where I was going to draw the green. And you can do that on your paper. I probably should have done the blue and dotted or something, okay? But you need to make clear what the graph is. Just erasing a few little random blue spots here so it's dotted, okay? This one, guys, what was this one? 5 pi over 4, 3. All right. We got to back up and talk about one more special graph. We haven't done any cosecant. Cotangent. Just kidding. Okay, cotangent's the reciprocal of tangent. 18A. There's the tangent graph in pencil, right? Cotangent, where it's 0, what happens? The reciprocal is undefined. So everywhere that this was a 0, this is going to be undefined. So where are those spots? X equals 0. What's the period? Because it's cotangent, the period is pi. So this next line is pi, and this next line is 2 pi. And there would be one, well, just kidding. All right. What's the reciprocal of a really tiny number? A really big number. What's going to happen in here? Okay, pi over 2, on my unit circle, pi over 2 is right up here, and that ordered pair is 0, 1. What is the definition of cotangent? X over y, so 0 over 1 is 0. So this is going to have a 0 here. What's a reciprocal of a really big number? A really small number. So we're doing this. It's the same, almost, as a flipped over it's like an upside down tangent graph, but what else has happened besides flipping it upside down? It's shifted, yes? Because a tangent looked like this, an upside down tangent would look like this, but they go through the origin. This is not going through the origin. Okay, we labeled asymptotes. I need a few ordered pairs. What are the intercepts here? Where's this? Halfway to pi is pi over 2, 0. Between pi and 2 pi is 3 pi over 2, 0. That's 2 periods worth, right? We're good. All right. I don't have a ton of time, so on those graphs, do you want to try this one? Let's do this one. This is at the bottom of 18A. What the quiz will say is you have to draw 2 periods, label the asymptotes and the maximums and minimum ordered pairs. Okay. What am I going to graph first? Okay. So I'm going to graph 2 cosine 3x, and I'm going to make mine dotted this time. All right. Okay. Amplitude. So it's going to go 2 to negative 2. What else? I'll just draw the cosine graph, and then we can go back and label the period. How's that sound? You're going to get the shape right? It should be symmetric with the y, right? You can keep going whichever ways you want here. Okay. Where does it finish this period where it went from maximum to maximum right there? Normally it would be 2 pi, but there was a b here, so it's 2 pi over 3. So where's this minimum then? Halfway to 2 pi over 3? Oh, guys, you got to have some fraction sense here. What's half of 2/3? 1/3? Halfway to 2 pi over 3 would be 1 pi over 3. And where's it at? It's at negative 2. That's a 2. That's a 2. This is 2 pi over 3, positive 2. This one over here is symmetric, so what's this one over here? It's the same thing, but on this side. Somebody help me. This point is the same over here. Negative pi over 3, negative 2. All right, how do I put in some asymptotes? Well, everywhere that the original one was crossing. Okay. So halfway to pi over 3. Woo. Half of pi over 3 is pi over 6. What's the period? 2 pi over 3. So we'd have to add that period on. Okay. 2 pi over 3 plus 1 pi over 6 is 5 pi over 6. It's 1 pi over 6, 2 pi over 6, 3 pi over 6, 4, 5 pi over 6, 6, 1 pi over 6, 2 pi over 6. That's not right. That's not right. Oh, because that's not a whole period. This is 5 pi over 6. What's halfway in between those? Three pi over 6, which is, guys, look at the original graph, right? If we put the, okay, I don't have time to keep going. I'm just going to draw it. So we have 0, 2 up here. We have some asymptotes labeled. We have some max and mins labeled. All right. We'll do a couple warm-up problems on this tomorrow, but then we're also going to talk about what would happen here. I got a minute. I'm going to do this one. This just stretches it up faster, but what does this do? The normal period is pi. What are we supposed to divide by? 1/4. Now, be careful. That means it does this and this by 1/4. Because remember, its symmetry is to the origin. All right, the homework is on the gold sheet. It says this. I have copies up here. If you want to copy the bookwork, they're in front of the blue basket. Copies are in front of the blue basket. Yes, yes. If it's a 4, no. You have your homework done. You just need to make test corrections. Does that make sense?